Estimating file sizes. Estimating file sizes is a vital part of designing any ICT system. Companies will need to think about how much data a system is likely to store for tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions, or even billions of records. This will allow them to know how much data they're going to need to buy servers for in order to store that data. So how many hard disks are going to have to buy, what sized hard disks, and it also has an impact on the speed of systems as well. The more data that systems hold, generally the slower they're likely to run. So it has big impacts on design for all organizations. When estimating file sizes, businesses are likely to be thinking about databases. That's where they store their data. So they need to be thinking about how big is my database going to be, how many rows are going to be in there, or how many records are going to be in there, and how many fields and what data type of the fields are. So if we went to the design of a database, we could see what the fields are, what data types they are, and even more detail about things like size of fields as well. So that's what happens in business in the real world. We'll talk a little bit more about how databases fit into capacity planning in a short while, but for the sake of the A-level, what we need to think about estimating file sizes for is text files. Certainly when we're thinking about the unit F452, it's just text files that we really need to think about estimating file sizes for. When you do the project in year 2 of your A-level, you may well need to think about estimating file sizes for a database, but we're going to just think about text files for now. So a text file will have, just like a database, if it's set up correctly, and this one is set up so there are commas that are delimiting the file, so there's a new bit of data after every comma in each row. They have fields and data types, but we've just got to know what they are. Now this actually is the same data that we saw in the database. So it's an ID, it's a game producer, a game title, a price, and the number of stock available for each title. So it's the same data in the database as it is in the text file. So we need to know that information. When estimating file sizes, there is a process that you need to work through, and in an exam you need to show you're working out as well. When real businesses do capacity planning, they may well do their file size estimations in a different way, but this is what you need to know in order to get the marks on the A-level. Firstly, you need to create some sort of table in Word or whatever and list the file design in that table. So when we say the file design, we mean you need to write down each field name and its data type. You then assume that every space taken in a text file, and when we say a space, I mean every character or symbol or number or whatever in there, that's what I'm referring to when I mean space. Every space taken in the text file takes up 1 byte of data storage, and we arrive at this because we know that extended ASCII, which we also know as ANSI, that character set takes up 8 bits, 1 byte. Therefore, each character in here takes up 1 byte. And to prove this to you, I'm just going to create a new text document, give it a name, and when we create it we can see it's actually 0 kilobytes in size, but because it says kilobytes there, I'm not actually going to use the standard Windows File Explorer because it measures file sizes in kilobytes. I'm actually going to use a piece of freeware which is called Explorer Squared. It's an excellent piece of freeware for file management, and there's the same file. It says 0 there, but it's actually measuring that in bytes, so that's going to be more useful for proving this. So if I go into that file now and just put any character from the ASCII extended ASCII key set into there, save that and close it, we can see that's now 1 byte. So that proves that when we're saving, with ANSI, that it's going to store 1 byte per space or character or symbol in the file. Now the next part of the process is to list the size of each field in bytes. Now if we look at the sort of data that we've got, even the first field, although it's 1 byte of storage there, further down it's going to be 2 bytes. So what you need to think about, what is my maximum size of each field going to be? So for a text field, it could be quite long, couldn't it? 30, 50 bytes, whatever. For a currency field, again, you're looking at around, we've got, say, a product that is $19.99, that is 6 bytes. So you need to think about what's the maximum size of each field, and you need to include that in your table. But we'll look at an example in a moment. Once you've listed all of the details about your file design, you need to add together the size of all fields in the table to find an estimation of the size of one row. You multiply the record or row size by the number of records in the file. You add 10% for what we call management overheads. Any piece of software you're working in will store extra data about how that piece of software should operate on the file. So 10% is a good number to add on for that. You then have your file size estimation in bytes. To convert that into kilobytes or megabytes or gigabytes or whatever, you divide by 1000 each time. So if we're going to convert bytes into kilobytes, we divide by 1000. If we then wanted to convert that into megabytes, we'd divide by a further 1000. Not necessary to divide by 1024 each time, as we are just estimating. So let's have a look at an example. So the first thing that I've done is I've made a table and I've listed the design of the file. I've talked about what the field names are and what data type each one is. Then you go and look at your data and you think about, well, how many bytes do I need from the first field? How many bytes would I need for my second field? How many characters, basically, is it likely to take up each? So for the ID field, we might say the maximum number of bytes might be 5. Once we get to the tens of thousands of different games in our database, we'd be looking at 5 bytes for the number 10,000, for example. For text fields, you might have some quite long titles of games and the producers, so I've said 30 for each of those. Price, we said 6. That's assuming a game never goes into the hundreds of pounds, so that's 1 byte for the pound sign, 2 bytes for the actual amount of pounds, a byte for the decimal point, and 2 bytes for the pence decimal places. And then stock availability, just in the hundreds, that means 3 bytes. Now what we do with that next is we add it all together to get the size of, or the estimated size of, one row or one record in our file. So all those added together equals 74 bytes. We then multiply it by the number of records in our file, how many records we're expecting in our file. There could be thousands, couldn't it, tens of thousands, millions in a business. But in this file, it's only 22, so that's the number I'm going to use here. And then those two numbers multiplied together come out as that. We're going to add 10% for overheads now, as the title suggests there. So that 10% of 1628 is roughly 163, so we add that on, and we get 1791 bytes. If we want to convert that to kilobytes, we just divide by 1000, as we said before, and we get roughly about 1.8 kilobytes as the size of that particular file. So we've estimated that the games products text file with 22 records in might be about 1.8 kilobytes in size. In reality, if we're going to have a look at the actual size of that file, it's only 881 bytes, so it's almost a whole kilobyte smaller than we'd estimated. So what are the reasons for that? Well, when you're estimating text file sizes, estimations are likely to be larger than the actual size, and the reasons for this are the overheads on text files are very small, so that 10% isn't maybe as necessary as it is working out the size of a file for a different type of file. Notepad doesn't require much data from a file to be able to work on it, so the overheads for a text file are very small. Also, we're estimating using the maximum possible field sizes. So an example was we said we'd allow for 5 bytes for the ID, whereas most of our IDs here are taking up either 1 or 2 bytes. And similarly for the text fields, we never use 30 bytes for those. So we can see why our actual real file size is a lot less than the estimation. Although this next bit isn't really too necessary for this type of question in an exam, it's just useful to know. We estimated our file size for 22 records might be about 1.8 kilobytes. If we go and look at the database equivalent, which has got the same 22 records in there, we can see it's a whopping 372 kilobytes roughly there. So much bigger than a text file with the equivalent data in there. And the reasons for that are estimations are likely to be much smaller than the actual size, because overheads on a database file are massive initially. Okay, so we're looking at almost 300 kilobytes of overhead on a database file. Another reason is databases store all records using the maximum field size. So if we declare in a database design that we want a text field to be 30 bytes in size, then Access will store that field for every row as 30 bytes, regardless of if it's only using 5 of them. So that's another part of the overheads on an Access database file. When our database gets bigger and bigger and bigger with more records on, any overheads are becoming less and less meaningful. But initially, as you can see, they cause the file to balloon massively into some big bloated thing compared to the text file. I hope that explanation of the process of estimating a text file size will be useful for your exam, and thinking about the database aspect of it useful for the project that you'll do in your second year on the A-level. And thank you very much for watching. Bye for now.